Hello students, welcome back to the classroom point. In our today's class, we shall discuss one of the most important concept, that is limiting reagent. And whenever a reaction is given, in that reaction, if different quantities of the reactants are given, then we have to find out the limiting reagent first. If limiting reagent is found, then calculation of the product becomes very easy. Now let us see what is the definition of the limiting reagent and how to identify it and how to solve the questions. Limiting reagent. The definition of limiting reagent is the reactant that is consumed first in a chemical reaction is called limiting reagent. And other reactants which are available still in the reaction called excess reagents. So limiting reagent definition says that any reactant, there may be two or more reactants, any reactant that is consumed first in a chemical reaction. Means if you take the two reactant molecules, in that two reactant molecules, which is going to completely convert into the product, and afterwards it is not available in the reaction mixture. So that reactant is called the limiting reagent. For example, if you take A plus B gives C, and A and B both are reacting and producing the product C. If A completely completed in the reaction and B is still available in the reaction, so which is completely consumed in the reaction, that is A. So A is called as the limiting reagent, and still whichever reactant is available in the reaction mixture is called as the excess reagent. Then let us see how the limiting reagent is deciding the products and how to identify the limiting reagent very easily. The amount of product produced in a chemical reaction depends on the limiting reagent. Then how to identify the limiting reagent? The reactant whichever is having less the value for the ratio of number of moles to its stoichiometric coefficients called limiting reagent. Now let us try to apply all these 3 points by taking one example. So example is, find the limiting reagent excess reagent mass of excess reagent left and mass of product formed when 10 grams of H2 reacts with 10 grams of O2 to form water at STP. So STP means H2O could be in the liquid state. That's why gases concept is not applicable here now. So now let us take the given question is solution. Reactants, two reactants are given, H2 and O2. So that write down the balanced equation. H2 reacts with O2 to form the H2O. This is the balanced equation. And see that how many number of moles and mass of the reactants are going to react with each other. So from the balanced equation, it is clear that 1 mole of H2 reacts with half a mole of oxygen to produce 1 mole of H2O molecule. In terms of the mass, see 2 hydrogen atoms are there in the H2 molecule. So that in terms of the mass, 2 grams of H2 reacts with, see this is 32 by 2, that means 16 grams. 16 grams of oxygen to produce 18 grams of the H2O molecule. So this is the information that we can get from the balanced chemical equation. But given information is different. Here given information is given data 10 grams of H2 and 10 grams of O2. So equal masses of the reactants are taken and asking us to calculate identify the limiting reagent, excess reagent, mass of the excess reagent and amount of the product that is going to produce in the chemical equation in this particular reaction. So our duty is we have to find out the limiting reagent first. So how to identify the limiting reagent? See the point here. The reactant whichever is having the less the value for the ratio of number of moles to its stoichiometric coefficients. Number of moles can be calculated from the given data and stoichiometric coefficients are nothing but the numbers we are using in the balanced chemical equation. So if before H2 here nothing is there means 1 could be there. That means its stoichiometric coefficient is 1. Here something is present. What is that? 1 by 2. So here stoichiometric coefficient is 1 by 2. Here also stoichiometric coefficient is 1. Anyhow, product stoichiometric coefficient not required for us because we consider only reactant side only because limiting reagent is only applicable to the reactants, not to the products. Now, let us find out the number of moles of each reactant. So, how to calculate number of moles? Given mass by molecular mass. Given mass is how much? 10 grams by its molecular mass of the H2 is 2 grams. And here given mass is how much? 10 grams. Molecular mass is 32 grams. So, this is the number of moles. Then number of moles by stoichiometric coefficients to find out the limiting reagent. So, number of moles by stoichiometric coefficient. So, number of moles 10 by 2 whole divided by 1, so that no change in the value here. But here 10 divided by 32 whole divided by 1 by 2 means it becomes again we can write down the 1 by 2 like this. So this equals to now in this particular area it becomes a 10 divided by 64. Here it is 10 by 2 whose value is less. See here. Both are having the same numerator value, but denominator value is more here. Higher the denominator value means automatically when same numerator value is there, then higher the denominator value will give the less value for that particular content. So here limiting reagent, this value is less, so that we can write down that limiting reagent is oxygen. So oxygen only limits the reaction. How oxygen limits the reaction? Let us see here. 2 grams of hydrogen we have taken and 16 grams. 2 grams reacts with the 16 grams and producing the 18 grams. For example, if you take the 4 grams of hydrogen and 16 grams of the oxygen, according to the equation, 2 grams reacts with 16 grams, then 4 grams needs 32 grams. But here again we have taken the 16 grams only. Even next time 4 grams is taken. That means still 2 grams of hydrogen is available in the reaction, but oxygen is not available. As long as other reactant is oxygen is not available, product cannot be formed. So that is the reason why the amount of the product produced can be limited by the amount of the limiting reagent. So only limiting reagent decides the amount of the product produced in the chemical reaction. As see here 4 grams we said, if 4 grams and 32 grams available means you will get the more amount of the water molecule, but here only 16 grams available, here 4 grams. So here hydrogen becomes the available in the more quantity, so that hydrogen can be called as the excess reagent. Now anyhow we found that limiting reagent is oxygen in this reaction and excess reagent is hydrogen. Now let us find out how much amount of the water, that is product, is going to produce. So from the balanced equation, 16 grams of oxygen is giving 18 grams of the water. See, whenever you are calculating the product here, once limiting reagent is decided, so we have to relate only limiting reagent with the product. Excess reagent has no role in this. So here 16 grams of oxygen is able to produce 18 grams of H2O. Then 10 grams can produce how much? 10 grams of O2 after reaction with the hydrogen, how much it can produce? So let us find out the mass of H2O produced. Do the cross multiplication. 10 into 18 divided by 16. So like this we can solve that. So it becomes now 90 by 8, 11.125 grams of the H2O can be produced in this equation. Now we have to find out one more thing, that is mass of excess reagent left in this particular reaction. See, actually here 2 grams needs 16 grams, then 10 grams needs more, but available is less. Now we have to find out how much of the H2 reacted within this 10 grams. So now see that 16 grams of oxygen can react with 2 grams of hydrogen. Then 10 grams can react with how many grams of hydrogen? 10 grams of oxygen can react with how many grams of the hydrogen? So mass of H2 reacted is equals to, do the cross multiplication, 2 into 10 divided by 16. So this goes 20 by 16, 1.25 grams. So it is 1.25 grams of H2 is enough to react. So out of 10 grams of hydrogen what we have taken, 1.25 grams of the hydrogen is consumed in the reaction. So remaining mass of H2 unreacted is equals to initial mass, total mass is 10 grams minus mass of the hydrogen reacted 1.25 grams. So this value equals to 8.75 grams of hydrogen is still available in the reaction and waiting for the oxygen to be available. So like this we can solve the questions of the limiting reagent, and let us see some more important questions which will give you good practice in understanding the limiting reagent concept. First you copy this one. Let us see the questions now. The given question is, in a reaction mixture, 8 moles of P react with 9 moles of Q in the following manner. So, balanced chemical equation is provided here. So, the equation is 2P plus 3Q gives 2R. Calculate the number of moles of R that is product is going to produce. So whenever this type of the questions are given, first of all we have to find out the limiting reagent. Even though they don't ask, we have to find out why, because the limiting reagent only limits the amount of the product formed. So according to the equation, balanced equation, 2 moles of P needs 3 moles of Q to produce 2 moles of R. Then what is the given data? Given data also given directly in terms of the moles only. 8 moles of P they have taken, and here Q is 9 moles of Q, and product has to be calculated. Then find out the number of moles to the stoichiometric coefficient ratio, number of moles to the stoichiometric coefficient. So here given number of moles 8 divided by stoichiometric coefficient 2. Here given number of moles are 9 and stoichiometric coefficient is 3. So it goes 4 times the ratio value, it goes 3 times. So the ratio value is this one. That means number of moles to stoichiometric coefficient value is less for the Q. That's why limiting reagent is Q. Then product has to be decided based on the limiting reagent only. That's why excess reagent we don't consider now. So how to calculate the number of moles of R formed? According to the balanced equation, 3 moles of Q is producing 2 moles of R. Then 9 moles of Q can produce how many moles of R? So number of moles of R that is going to produce is, just do the cross multiplication, 9 into 2 divided by 3. So this value is equals to 6 moles of R is going to produce in this reaction. Now let us see one more equation. In a reaction, A plus B2 gives AB2. Identify the limiting reagent, if any, in the following reaction mixtures. So for the same reaction, they had given the different combinations using the atoms votes, number of moles votes, or the different combinations they have taken. Let us try to see how to solve this one. Solution. So given reaction is A plus B2 gives AB2. So from the balanced equation, see this is the atom directly given, but B is given in terms of the molecule. So 1 mole of A atoms reacts with 1 mole of the B2 molecule, because here stoichiometric coefficient is only 1. Here also only 1. Here also only 1. So that we can write down that 1 mole of A reacts with 1 mole of B2 and giving 1 mole of AB2 molecule. If you take in terms of the atoms, 1 atom reacts with 1 molecule giving 1 molecule of AB2. If you take moles, 1 mole reacts with 1 mole of the molecule giving 1 mole of the molecule. Now let us see the given options here. From the first option, 300 atoms of A reacts with 200 molecules of the B. So here if you consider according to the atoms, means number wise, 1 atom reacts with 1 molecule. So 300 atoms reacts with 300 molecules. But how many molecules are available? Only 200 molecules are available. That means B is available in the less quantity. That's why limiting reagent in this combination is B. Now see the second one. 2 moles of A reacts with 3 moles of B. According to the mole-mole relation, 1 mole reacts with 1 mole. 2 moles reacts with 2 moles. But here B is available 3 moles. That means B is excess reagent. So limiting reagent is A. Next, 100 atoms of A reacts with 100 molecules of the B. 1 atom reacts with 1 molecule. 100 atoms reacts to 100 molecules. Here also 100 atoms, 100 molecules are produced. So in this combination, there is no limiting reagent. Next, let us see the fourth one. 5 moles of A reacts with 2.5 moles of the B. Just now already we have discussed that 1 mole needs 1 mole, 5 moles of A needs 5 moles of the B, but only 2.5 moles of B is available. So in this combination, limiting reagent is B. Now let us see 2.5 moles of A reacts with 5 moles of the B here. Combination is given. 2.5 moles needs only 2.5 moles of the B, but 5 moles of B is available. That means B is available in the excess and A is available in the limited. That's why limiting reagent is A in this reaction. Now let us see some more questions. So here the given question is X grams of zinc metal was mixed with 2x grams of iodine to form zinc iodide. Which of the reactant will remain excess and what fraction of it remain unreacted? So we have to find out the excess reagent and whatever excess reagent still available in the reaction, that means not reacted, both we have to find out. So when you are finding the excess reagent means automatically we are finding the limiting reagent also. So let us see both. So first of all, let's write down the balanced equation. Zinc reacts with I2 molecule to form zinc iodide. Let us see the given data. X grams of zinc. So mass of the zinc given as X grams of zinc reacts with 2x grams of iodine. This we don't know anyhow. So let us find out the number of moles of both of these reactants, zinc and iodine. Number of moles, weight by atomic mass here. Weight is X grams. Divided by atomic mass already given, that is 65. Here weight 2x grams. I2 atomic mass is 127. I2 means molecule, that is 254. So it goes 127. So the value of this part is equals to X divided by 127. See, both are having the same number, that means the numerator value, denominator value is higher here. At the same time, stoichiometry coefficients for both is only 1. That's why the ratio of number of moles to stoichiometry coefficients also produce the same value once again. That means X divided by 65 here, X divided by 127. So the limiting reagent can easily be understood that iodine is the limiting reagent here. So limiting reagent is iodine and excess reagent is zinc. So this zinc. Now let us find out how much of the zinc is not reacted. See, X by 65 grams of the zinc on reaction with X by 127 means out of this much has gone. Remaining is unreacted. So mass of zinc unreacted is equals to X divided by 65 minus X divided by 127. That much mass reacted and remaining mass is not reacted. But they're asking what fraction of it remain unreacted. So fraction of zinc unreacted is equals to still available unreacted mass, that is X divided by 65 minus X divided by 127 divided by total mass of the zinc, that means total number of moles of the zinc taken, that is X divided by 65. By solving this we get the 0.48 fraction. This much of the zinc is not reacted. So these mean number of moles. So these mean number of moles reacted, remaining is unreacted number of moles divided by total number of moles, we got the fraction. Now let us see one more reaction. In this reaction, 10 grams of calcium carbonate is reacted with 10 grams of HCl. What mass of CO2 will be produced and which reactant is the limiting reagent? Now let us see here the solution and write down the balanced chemical equation for this. Calcium carbonate on reaction with 2 moles of HCl to produce CaCl2 plus CO2 and H2O. So our relation is with only calcium carbonate, HCl and CO2. So these two products we don't consider here. So first of all, let us write down the given data. So given data is 10 grams of calcium carbonate reacts with 10 grams of HCl. We don't know how much is going to produce here. Then calculate the number of moles of both of these reactants. How to calculate number of moles? Given mass by molecular mass. Molecular mass of the calcium carbonate is 100, whereas 10 by molecular mass of the HCl is 36.5. Then both are having the same numerator value, denominator value is higher here. So calcium carbonate is having the least value. And let us see the number of moles by stoichiometric coefficients also. So here 10 divided by 100 divided by only 1, so that the value do not change here. But here 10 divided by 36.5 again divide by 2, so that here we can write down that 2. So final value again is equals, denominator value is higher for the calcium carbonate. So calcium carbonate is the limiting reagent. So limiting reagent is equals to calcium carbonate, and excess reagent is equals to HCl is available. So mass of the CO2 produced. So mass of the product produced always depends upon the mass of the or quantity of the limiting reagent only here. So if you see the balanced equation, CaCO3 balanced equation, from the balanced equation 100 grams of CaCO3 is going to produce 44 grams of the carbon dioxide. Then 10 grams of the calcium carbonate can produce how many grams of the carbon dioxide? So let us write down that 100 grams of CaCO3 is producing 44 grams of carbon dioxide, but only 10 grams of, that is what limiting reagent here we have considered, can produce how much mass of the carbon dioxide. So mass of CO2 is equals to the cross multiplication 10 into 44 divided by 100. So this is equals to 4.4 grams. Let's see some more questions. 50 kg of N2 and 10 kg of H2 are mixed to produce ammonia. Calculate the ammonia formed. Identify the limiting reagent. So let us try to write down the balanced chemical equation for this. So here nitrogen reacts with hydrogen to give 2 moles of ammonia. So from the balanced equation, we know that 1 mole of nitrogen reacts with 3 moles of H2 and is producing the 2 moles of ammonia. And one more thing here is, if you convert them into in terms of the mass, 28 grams of nitrogen reacts with 3 into 2, that means 6 grams of hydrogen, and is producing 2 into 17 grams of ammonia. Here you can take in terms of the kg also, because the values are given as kg. So what is the given data here? Given data is 50 kg of nitrogen and 10 kg of hydrogen reacting, so that how much amount of the ammonia will be produced and what is the limiting reagent. So find out the number of moles of both reactants. How to find out the number of moles? Mass by molecular mass. Here mass is given in the kg, so you take the molecular mass also, you consider them as a kg. So instead of 28 grams, I am considering it as a 28 kg now. So that here 50 divided by 28, here 10 divided by molecular mass, not the total this mass. So molecular mass is only 2. Then stoichiometric coefficient, number of moles divided by stoichiometric coefficients is equals to, so number of moles how much is given? This is the number of moles, 50 by 28, stoichiometric coefficient is only 1. So the same value will get it, 50 divided by 28. But here stoichiometry coefficient is 3. So that 10 divided by 2 into 3, that is equals to here 10 upon 6. So by solving this, you will get that the limiting reagent is hydrogen. Limiting reagent is equals to H2. Now let us try to find out that is the mass of ammonia that going to produce. So mass of the product produced always depends upon the limiting reagent. That means 6 grams, or else you consider it as 6 kg. 6 kg of hydrogen was able to produce 2 into 17, that means 34 kg of ammonia. Then 10 kg of hydrogen can produce how many kgs of ammonia? So mass of ammonia produced is equals to, do the cross multiplication, 10 into 34 divided by 6. So you'll get the 56.6 kg of ammonia is going to produce in this reaction. Let us see one more equation. This question, if 0.5 moles of CaBr2, calcium bromide, so calcium bromide is mixed with 0.2 moles of potassium phosphate, so K3PO4, to produce the maximum number of moles of calcium phosphate that can be produced is. So let's write down the equation here. Ca3PO4 taken twice, and potassium combines with the bromine to form the potassium bromide. Here 3 calciums are there, so you put here 3, so 3 into 6 bromine, so that here 6 bromine, so 6 potassium, so that 2 into 3 equals to 6 potassium, balanced. Equation is balanced. Now 2 phosphate also present. So from the balanced equation, 3 moles, this is from balanced equation. Information from the balanced equation is 3 moles of calcium bromide reacts with 2 moles of calcium phosphate to produce only 1 mole of calcium phosphate. But what is the given data here? Given number of moles, 0.5 moles of calcium bromide and 0.2 moles of potassium phosphate they had given. Then find out the number of moles to stoichiometry coefficient. Number of moles 0.5 divided by stoichiometry coefficient is 3 here. And here 0.2 given number of moles, and stoichiometry coefficient is also 2 here. So let us try to solve this one. This will give the 0.1 and this will give you the 0.166 moles. So the value is least for the this is the value ratio. The value is least for the potassium phosphate, so that limiting reagent is K3PO4. Now the moles of calcium phosphate produced depends upon the limiting reagent potassium phosphate. See, from the balanced equation, 2 moles are giving the 1 mole. Then 0.2 moles can produce how many moles? That could be 0.1 moles. Let us see here. So 2 moles producing 1 mole of calcium phosphate. Then 0.2 moles can produce how many moles of calcium phosphate? So number of moles of calcium phosphate that is going to produce equal to the cross multiplication, 0.2 into 1 by 2, that value equals to 0.1 mole of calcium phosphate is going to produce. So let us see this question now. The question is, upon mixing 100 ml of 0.1 m potassium sulfate. So they have taken the potassium sulfate that mixed with 100 ml of 0.5 m barium chloride. So barium chloride and a precipitation of barium sulfate takes place. So BaSO4 precipitate is formed. How many moles of barium sulfate is formed? Calculate the molar concentration of this species left behind in the solution, which is the limiting range. So much of calculations are there. Let us do that. So first of all, let us balance this equation. It is 2 chlorine, so that 2 KCl, potassium chloride. So from this equation, given information is 1 mole of potassium sulfate reacts with 1 mole of barium chloride, giving 1 mole of the barium sulfate and 2 moles of the potassium chloride. That is the balanced equation information. Let us take the how many millimoles of the potassium sulfate. See here, milliliters are given, so that I am going to calculate the information in terms of the millimoles. So that let us try to see that millimoles. Number of millimoles of the potassium sulfate and barium chloride. Molarity into milliliters gives the millimoles. Molarity into liters gives the moles. So that here 0.1 into 100, that equals to 10. So 10 millimoles of potassium sulfate reacts with, and here 100 into 0.05. So that is equals to 5 millimoles. And stoichiometric coefficients, only 1. So number of moles to the stoichiometric coefficients, same 10 by 1. This is 5 by 1. So this is 10, this is 5. So less available is barium chloride. So barium chloride is the limiting reagent. So limiting reagent is equals to barium chloride. So let us try to find out the number of moles of barium sulfate formed. See here, 1 mole of barium chloride gives 1 mole of barium sulfate. Then 5 millimoles of barium chloride gives how many moles of this one? So let us consider here also millimoles. 1 millimole of barium chloride gives 1 millimole of barium sulfate. Then 5 millimoles gives, barium chloride gives how many millimoles? That means number of millimoles of barium sulfate is equals to 5 millimoles. So if you want the number of moles of the barium sulfate, then 5 into milli value 10 power minus 3 into mole. That means 0.005 moles of barium sulfate is produced. So how many moles of barium sulfate is produced? This part is over. 5 moles of 0.005 or 5 in 10 power minus 3 moles of barium sulfate is going to produce. Now they are asking calculate the molar concentration of the species left behind. For that we need to calculate the total volume of the solution first of all. So total volume of the solution is equals to, there are two solutions, 100 plus 100 ml. So that 100 ml plus 100 ml gives 200 ml of the solution. Now they are asking calculate the molar concentration of the species left behind in the solution. So which are the species left behind here? Potassium sulfate is left behind, and barium sulfate, anyhow moles we calculated, potassium chloride, both are left behind in the solution. So let us try to calculate here. See, 10 millimoles reacts with, according to the equation, 1 millimole react with 1 millimole. 10 millimoles must react with 10 millimoles, but only 5 millimoles are available. That means this 5 millimoles react with the 5 millimoles of the potassium sulfate. So still 5 millimoles of potassium sulfate is available in the reaction. So number of millimoles of K2SO4 left in the solution is equals to 5 millimoles. Let us find out number of moles. Number of moles of potassium sulfate equals to 5 into 10 power minus 3 moles. Then they are asking to calculate the concentration, molar concentration. So concentration, that means molarity of potassium sulfate is equals number of moles per liter. So number of moles, how many given here? 5 into 10 power minus 3, that is the number of moles. Given volume is 200 ml, that means 1000 by 200. So this value cancel out. So 5 into 10 power minus 2 by 2, that value equals to 2.5 into 10 power minus 2 is the molarity of the potassium sulfate. Now let us try to calculate the other things also. Then number of moles of the already barium sulfate is formed. So barium sulfate concentration also we can calculate it. So that molarity of the barium sulfate. So number of moles, how many are there? 5 into 10 power minus 3 into 10 power 3 divided by 200. It cancel out, same value will get it. That is 2.5 into 10 power minus 2 molarity. Then we need to calculate the molarity of the potassium chloride. See that the number of moles of potassium chloride according to the balanced equation is twice the barium sulfate. So molarity also will be twice the barium sulfate. So molarity of the potassium chloride is equals to 2.5 into 2 into 10 power minus 2 m. That value is equals to 5 into 10 power minus 2 m is the molarity of the remaining species in the equation. And here barium chloride we don't calculate because already we said that it is a limiting reagent. Limiting reagent always consumed completely in the reaction. So dear students, I hope you understand this limiting reagent concept, and before solving the questions, you copy the question and try yourself. If you don't get it, again you can get the solution immediately there only. So pause the videos, then see you yourself try the questions, then check your answers. So if you understand these videos, please do share with your friends and do not forget to subscribe the channel. Thank you one and all.